Hello everyone, a very good afternoon to all of you. Thank you all the attendees for joining us today. I hope all the attendees had a great time networking with your peers in our networking lounges. I am Priyanshi welcoming you all on behalf of Solar Quarter and First View Group to our webinar on redefining inverter standards in the solar industry. So before starting today's proceeding, I take this opportunity to thank and welcome our partner for this event, SUNGROW. We have a short video of our partner SUNGROW requesting my team to please play the video.
We are the first supplier to launch world's first biggest rating in terms of string inverter, that is a 250HX that was giving 250 kilowatt active power.
We are coming up with this 10 gigawatt setup, which is going to have the SMT line manufacturing. So it means all the PCBs which we are using in our inverter is going to manufacture locally.
With the new factory that we have in place in Bangalore is going to bring this concept vocal for local.
This is a clean room concept with the ASD flooring. This clean room concept is used to manufacture the string inverter assembly. This string inverter assembly has got a n number of stages. Few stages will be used to assemble the inverter, and another few stages will be used to quality control, production inspection and testing. This is the aging room. This aging room is used to perform the heat run test for the string inverter. Whatever we are manufacturing, 100% inverter will be tested in this chamber. Due to this, we can meet the customer OTD. OTD means on-time delivery can be met for the customer very easily, and we can deliver a very good and quality-oriented product to the customers.
SUNGROW has done almost $16 million investment in India, which clearly demonstrates that our presence in India is for long. That promotes customer confidence. Also, the leadership in India has been given with good authority to take the decisions. So that is the best part in SUNGROW India, where the leaders enjoy to take the drive and also deliver to the customer.
Thank you so much team for playing the sponsor video. Now, without any delay, let's begin our session, and this session will be starting with a sponsor presentation by Mr. Rishabh Anand from SUNGROW. Welcome on the screen, sir.
Thank you very much, Priyanshi. I'll just share my screen.
Sure, sir. Please.
A warm welcome to all the STM panelists and all the guests who are attending this webinar today. Are you able to see my screen?
Yes, sir.
Welcome everybody to webinar on redefining inverter standards. My name is Rishabh Anand. I take care of technical of the North India region for SUNGROW India, and I will be starting my presentation. Have a look once more. So, who is SUNGROW? So, SUNGROW is the world's most bankable inverter brand, which is 100% bankable for the last 3 consecutive years. as per Bloomberg NEF studies. So our company culture, as you can see, we were started in 1997, and we have moved from step to step. And in 2021, now we are ranked amongst China's top 500 ESG excellent companies. Our mission is Clean Path for All, and our vision is to be the global leader.
Disturb you, but your slides are not changing.
Just a moment.
And make it presentation view, Rishabh.
Just a moment, sir. Sorry for the delay. I hope my screen is visible now. So, as a company, our mission is Clean Path for All, and our vision is to be the global leader in clean energy conversion technology. Our values are sincere and pragmatic, precise and open, and being customer oriented. So, our top 10 businesses are PV inverter business, renewable energy investment and development business, energy storage converter and system, wind energy converter, new electric vehicle driving system, floating PV system, smart operation and maintenance, electric vehicle charging equipment, intelligent PV cleaning robot, and renewable hydrogen.
Sorry to disturb you again. Can you please do the full screen, sir? We are not able to see the presentation properly. Can you make it a slideshow? Because we are not able to see the presentation properly, sir.
Just
You could put it on presentation mode. Yes.
The fourth button in the bottom row, right side. Next. That one, yes.
Requesting the attendees to kindly hold on for a minute. We'll start with the presentation soon.
I'll try sharing the PDF.
Sure, sir. Sure. So can you just do it like you did in the rehearsal session? It was explained perfectly at that time. Yes, sir. Yes, sir. It's perfect. It's perfect, sir. Please continue.
Okay. That is the problem. It is not coming in the proper manner. Just a moment, please.
So if you don't mind, can we start with the panel discussion and later on we can have your presentation? If that is okay for you.
Yeah, that also seems to be okay. We can continue with the panel discussion.
Okay, that's fine. So let's begin with our panel discussion, which is on redefining inverter standards in the solar industry. And to discuss this, we have in the panel with us Mr. Atul Panchori from O2 Power, Mr. Rishabh Anand from SUNGROW, Mr. Rabindran Sundar Singh from ACME, Mr. Rajesh Tiwari from Hero Future Energies, and Mr. C. Chaudhary from Sterlite Power. Now I welcome all the panelists on the screen and requesting Atul sir to lead the discussion. Before that, I would like to make a small announcement here, requesting all the attendees to post your questions on the Q&A box. Our panelists will take those questions at the end of the panel discussion. Thank you. Atul sir, over to you.
Thank you, Priyanshi, for giving me the opportunity to bring
इसमें
on
बढ़िया से सही
table
करके देख लो.
many experts on the same table. So, so to start with this panel discussion, so I would like to emphasize on one basic topic which I think every listener and every speaker should make a note of it, because we have seen in last few days, few months, sorry, we have seen that few accidents have happened at site, right? Specifically on wind and solar sites. So these are very specific issues. So everybody should take a safety pause before starting any work. Okay, so it is a very necessary requirement, so everybody take a note of it, because every life is very important for that individual and their family. So we have to take very seriously the safety things. So thank you all again. So I would like to start this session with a very quick intro from all the panelists side. So let's start with Rishabh. So Rishabh, if you can give a quick intro, then we can go to Mr. Ravindran, then Rajesh ji, and then fit to Mr. Chaudhary. Please.
So yeah, we have currently launched the inverter, which is SG320HX. So SG320HX comes in is the largest string inverter as of now available in the industry. That is a 295 kilowatt inverter that is available, and this inverter comes in two variants. One variant is with 30 amps MPPT current, and another variant is with 40 amps MPPT current. The purpose of having two different variants for this inverter was since you have two different wafer sizes which are existing predominantly in the industry, one being the M10 wafer, which is the 182 wafer size, and another being the G12 with the 210 wafer size. So both have different characteristics and different output current. So catering to both the requirements of the industry, we have created two variants of this inverter. So one will have 30 amps MPPT current and another one will have 40 amps current. And this inverter has a host of safety and other features which are prevalent in the string inverters. Like it will have insulation monitoring, you have support for anti-BID, Q at night, all the functions which are required for a string inverter are available. And there is another plus point for this inverter is the fast response times which are available with this inverter to cater to the grid dispatch, which is highly required in this day and age. So this is about this inverter.
So okay, Rishabh. So I was expecting your introduction rather than your product, but okay, fine. We can move ahead with Rajesh sir. So Rajesh sir, over to you.
Thank you, Atulji. It was first of all, I would like to thank you, Solar Quarter, for organizing such a wonderful event, and this is a very meaningful event. About me, basically, I am working as a assistant vice president in Hero Future Energy. Here, my role is basically to lead the utility scale solar power plant design division, and basically we manage a complete portfolio of more than 1.5 gigawatt. It's a solar plus wind, as well as nowadays the hybrid and other international projects also we are maintaining in Ukraine and in Bangladesh also. We are coming up with the projects. So this, over to you.
Right. So next, I'll request Rabindran sir to introduce.
Hi, good evening, everyone. I'm Rabindran. I'm CTO at Renewables. City Renewables at Acme. I've been in this renewable sector now for almost 7 years. Prior to that, I was in thermal, gas, hydro, transmission, all these allied areas. I've done design, a little bit of maintenance, lots of commissioning, and project development, and so on. Very happy to be here with you and join in the discussion. Thank you.
Thank you. So over to me only. So myself, Atul Pachori.
Yeah.
I am leading operations at O2 Power, and also leads the commissioning process at O2 Power. And we are doing solar power projects currently, and in acquisition mode also. We have acquired a few projects in the state of Karnataka also. We have a big pipeline of around 2 gigawatts for next 2 to 3 years. We are more targeting on some different technologies like hybrid and wind also. So that's about me and O2 Power. So let's start the discussion. So in the recent announced Indian Economic Survey, maybe perhaps the first time, dedicated a whole section on the Sustainable Development Goal and climate change altogether, and thereby exhibiting the increasing importance. According to it, definitely the section tackled the progress of the SDGs in India, highlighting a progress of the various stages, including SDG 7, which is focused on affordable and clean energy for all. So India, being a very fast runner and track record in renewable energy at COP26, India set a target to achieve non-fossil fuel-based installed capacity of up to 500 gigawatts by 2030. So I'm sure that without the inverter it is not possible, because wind alone cannot tackle all the things. India added a record 10 gigawatt of solar energy to its cumulative installed capacity in 2021. So it is a very remarkable journey, and has shown a growth of nearly 200% year on year. So inverter being a key component of the solar PV plants, and definitely it needs a special attention from all, being it be a power developer or a EPC contractor or a O&M service provider or being the OEM. So it is being an intelligent electronic device and a very smart thing. So we need to take care of the IED also at the same time. So be it the CEM requirements or the grid code compliances or the local substation requirements for active power, reactive power, power factor, voltage, and frequency response, all are being managed and controlled by the inverter, and definitely governed by the power plant controller. So today's discussion is really very interesting. So I'd like to put a question to definitely SUNGROW team, that how compatible is the high power, because you are increasing the power of the string inverter itself, and with the new age formats, like we are introducing bifacial modules. Okay, the tracker systems also are being introduced at the same time. So it is making the things complex as far as the solar simplification is concerned. So how compatible is it?
Yeah, thank you so much, sir. My apologies, I got your initial question wrong for introduction. So my name is Rishabh Anand, and I am taking care of technical in North India for SUNGROW India Private Limited. And now I'll move on to the answer for this question. So our product, we also understand that there are different formats of modules which are coming in the market. And to cater to that, we have two variants of product, SD320HX, which is the leading solar utility inverter. So we are catering to 182 mm wafers as well as 410 mm wafers. So it will have 30 amps and 40 amps respectively MPPT current. And with regard to tracker, basically tracker usually optimizes the generation of the plant. So the inverter actually aids the tracker performance by virtue of tracking the string voltages, string current, and the power. And there is a mechanism in this inverter wherein via open protocol, it can give feedback to the tracker controllers to optimize the tracking angles based on several algorithms, based on the type of land, the morning and evening sunlight angles, and the time of the day, and time of the year, how the season is there, whether it is snowing or it is a barren land. So based on all these things, we have developed algorithms which can give open communication protocol feedback to the tracker system to further optimize and increase the generation of the plant. So wherever such technologies are being used, because trackers inherently will not have such precise information after installation at a site. So such information is very valuable, and it can certainly increase the generation of the plant. So that is from my side.
Right, Rishabh. This is really very interesting to know that the trackers are open to communicate with not only with the SCADA system but with the other peripheral smart systems. So that will give a added advantage. I must understand. So that was a view from the OEM side. So I would like to invite Rajesh sir also to put some light as a IPP also.
Thank you, Atulji. Basically, advancement and the increase in efficiency, and this is must needed. Basically, if we talk about a string inverter, uh, the day when 40 kTL or 43 kTL or even 16 kilowatt was there. So after that, like single phase to three phase and three phase to now, it is like moving ahead on the 500 kilowatt, you can say. So 1000 volt to 1500 volt. So definitely this will give the advantage. The kind of product, if a string inverter, if we talk, that is coming up with a 350 kilowatt, and Bizarb is like 16 MPP inputs, and here is a 12 input. So definitely there will be advantage. 30 ampere to 40 ampere, this will be advantage, because while designing, we were facing a lot of difficulty, because module manufacturers, they were having a two different philosophies. One is like higher current, somewhere they are giving a 17 ampere or more than higher current, and some module supplier, they are giving 13 ampere in compared to the 550 or 560 watt peak modules. So there, it's really was the difficult, if both 30 or 40 ampere or either 40 amperes input will be there, then it will be better to have a branch connector, and we can take it forward, and we can further reduce our BUS cost. So this is one of the best thing I think SUNGROW is taking up. This was really one of the biggest challenge. As per in other side, if we talk like interfacing side, so 800 volt and 800 volt related MCCB. There also, I think they can support to some OEMs or the MCCB manufacturer. That is one of the big challenge we are facing. So although the higher size of the inverter will definitely reduce the BOS cost. Yes.
Right. So being the largest, one of the largest purchaser of these inverters and such components, so
Yeah.
I'll ask Ravindran sir to put some light on it.
Yeah, it's thank you, Atul. It's very relevant that SUNGROW has come out with this a differentiated model to exactly match the module characteristics. We've been realizing over the years that the good control of, for example, the MPPT, the temperature range, the current range, all these are impacting the performance of the inverter in very invisible ways. These are things which the user cannot really perceive easily, and by the time you finish troubleshooting, you've lost a lot of energy. So it's good that the OEMs have come together to match the technology with the module. I expect another big step when they move into 2000 volts with the modules, and similar in same time frame, then the inverter manufacturers will have to adapt.
Right. So my submission is very futuristic actually, because when we are talking about the new module technology, so when we are trying to buy the module, everybody is buying the bifacial module nowadays. But if we will see the track record of a bifacial module, nobody have a very large track record, especially in India. We do not have that much. So in the futuristic context, we can see a degradation pattern. Obviously, means every module is tend to degrade of its lifetime. So when we'll be having a degradation pattern, so in current scenario, we'll see in the polycrystalline modules or thin film modules, degradation actually differs from module to module. Okay, so when we are looking after a plant which is, let's say, 5 years old or 6 years old or maybe 10 years old, we can see a very highly differentiated degradation pattern, right? So which makes the mismatch losses very high, right? So after that, few people do exercises like to do the IV curve testing and to segregate the modules which are having common degradation in one string and in another string. So it is very important, because when we design the plant, we consider, let's say, 1 or 2 or 3% of the mismatch losses maximum. But when we see practically after 5 years, the mismatch losses are really going very high. So if we are having the string inverters in place, then definitely the segregation of those modules which are having different set patterns of the degradation, that will become easier for the plant owners, right? So again, there is a debate. Means every time I used to listen this debate whether to install the central inverter or whether to install the string inverter, which is much more important or lucrative in terms of matching the IRRs or assumptions and every other thing. So I'll ask Rajesh sir to throw a light on it as a IPP and the operator of the plant.
Definitely. See, actually, comparison with string inverter and central inverter, both are in the same family, and both are having basically, we can say, very important part of the solar power plant. This is ultimately a kind of people say heart, brain. Algorithm based a machine which gives a performance guarantee. If we compare the kind of scenarios now is going on, there are 1500 acre or your 1000 acre plant. So big scale projects are coming. In the big scale projects, there are two and three much more number of variability. Your terrain is not flat. You have a lot of undulation, and because of the undulations, you may not be able to maintain a same pitch, or even you will not be able to maintain the flat. So there your string inverter will give you the better, because of the MPPT, they can give you the better yield. Second, uh, also we can say about the maximum number of MPPT. So when you tell about the different wattage of module, because for a 500 megawatt project or 375 megawatt project, it is not easy to have one make of or single wattage of module. You will have at least 4 or 5 OEMs supply, and they will give you a mono perk or mono or something. You It will be on your choice, like bifacial as well. So there, because of MPPT, you can able to maintain the minimize the mismatch loss. And string inverter, if I see, because of the cloud variation and lot of other things, even control side also, string inverter have a little faster. But yes, of course, in the communication side, because the 1000 nodes are working, so in parallel to the PPC, there is a inverters, because PPC ultimately has to read the command, and then he has to write, and then he has to forward to the inverter. So there the delay, there somehow the string inverter get lag on the central inverter. But as far as I found about the LCOE part, the string inverter is one of the best friend for us. So I think string inverter will win the race on this. Yeah.
Right. So very to me, sir, touchy topic you have touched, Rajesh sir.
Yeah.
Rishabh, do you have anything to say about the control on the speed, and how fast acting the inverters can be when we are controlling them from PPC?
Sir, I would like to come in this. There is a fact that you have more number of string inverters being connected to a block. Vis-a-vis, same thing with the central inverter. There you will be having 1, 2, or maybe 4 central inverters placed in a block. whereas you will have a large number of string inverters that are being placed in vicinity of each other that comprise of a block. So here, with respect to grid compliance, it will meet the requirement, but the controller, which is controlling the entire block level string inverters, has to act very fast. And the string level DSP should also react to the messaging that has come from the controller in a very fast manner. So another thing I would like to stress upon here is that at the plant, at the block level, you can have multiple other type of interfaces like IEC 104 protocol, or there is a protocol called Goose protocol, Grid Object Oriented Substation Event Protocol. So that will bypass several layers of acknowledgement, and it can straight away publish the command, and the command can be acted upon in a very faster manner. So these are the upcoming things that are coming in this field, which can allow the block level responses to be faster for string inverters as well. So, sir, this is my viewpoint to this.
This is again a very interesting thing for everybody to listen, because I was behind the inverter suppliers that get rid of Modbus TCP/IP, boss. Okay, so if SUNGROW is really interested in giving the communication over IEC 104 or either IEC 61850, okay, so whose messaging comes on that. So 61850 as well as IEC 104, both are really versatile protocol, and definitely it will increase the speed and to and fro commands with the PPC or SCADA system. So interesting, very good. So means it's good for everybody that people are open for changing their protocols from Modbus to other faster acting protocols, right? So Ravindran
So
sir,
in many cases, the encapsulation will be TCP/IP, that is like Ethernet interface. But there is a provision that you can opt for a faster acting protocol if there is a requirement on the grid side to respond in a faster manner.
that is the key, because in today's scenario, whenever either PGCI is testing or POSOCO is testing or state grids are testing, nobody is very much serious in testing those things. But in other countries, if you compare like UAE or maybe Australia or maybe United States, there without testing or the speed command response or whatever response, nobody is allowed to commission the plant also, right? So not far the days are when India also have to follow those things. So I'll request Ravindran sir to put some light.
Okay, thanks. If it's a comparison of central and string, I'm still sitting on the fence. I see several advantages for string, and equally several other advantages for central. Right, some of these have already been mentioned by Rajesh. Some you have said on the side of grid performance, grid compliance. There are so many things to comply to. The steady state compliance in terms of voltage, current, voltage and frequency, and then the transient response, which is essentially how does the inverter behave when there is a fault. What does it do during the fault? What does it do after the fault? Uh, in the transient period, is it contributing enough fault current to bring up the voltage? Now, so many attributes are required. So I do find that central inverters are better equipped to really respond to grid situations. But on the flip side, string inverters, I love the fact that when I commission a plant for the first time, on day one, I know exactly out of my 1 lakh strings which strings are not working, which are requiring what intervention. Right? One of the biggest losses for IPPs is that first few weeks or months which they waste in literally recommissioning the plant. I hate this concept that we commission something but it is not really commissioned. And in such a case, the string inverter really helps us in visualizing totally where my generation, if at all I'm losing something, where it is going. Right? So these are good advantages. Some other things about multiple MPPT mismatch, all those are known facts, especially if I'm doing bifacial. If I'm doing bifacial on, say, fixed tilt, I have 2 rows of bifacial. The way they are arranged, the upper row has more radiation coming from the rear. So I have a straightaway a mismatch between the two rows. So the string can take care of all this. The string inverter can handle such things better. There are central inverters coming up with multiple MPPTs, but that's not the same thing.
So rightly said, Ravindran sir, because people may or may not acknowledge the fact that for the first few weeks, let's say for 5 weeks or maybe 6 weeks, also for the stabilization time, we are losing a lot of energy, that we are not reaching up to our top performance, and definitely nobody knows that how many strings are under breakdown and where those strings are located, because nowadays we are not choosing the string monitoring also. Okay, everybody is going with the SCBs only, and during that phase, if we can counter, if you can give a weightage, a proper weightage while we are modeling the cost, because cost is the prime governor for selection of the string inverter or the central inverter. So definitely this is a very good topic that everybody, the modeling people who are doing the modeling should put a weightage, let's say X or Y or Z, whatever the weightage, for first few weeks also, that how much energy we'll be losing in terms of this is really interesting. Yes, right. So let's move ahead, and regarding the in the last many years, 10 years, we have seen that many plants have been completely vanished off due to PID, right? And PID was a major factor that the modules got underperformance, and people were struggling for getting the warranties also for the modules which are getting affected by the PID. So that was a major drawback for that. And still, in if we are seeing in the central inverters, the negative grounding is available, and we have to stop that PID for any module. So, and in central inverter, they are giving some provision for it as anti PID kit or something. But yes, so Rishabh, you please put some light more on it, that how you are protecting that PID, and how much benefited it is for the people, for the IPPs, because module degradation, natural degradation, maybe okay, fine, 1%, 2%, or 5%, people can model it and people can see it. But if we are having a PID impact on the plant, then we are not saved at all.
Absolutely correct, sir. Actually, a solar panel is a chemical, is a combination of two chemicals which are there. It's a PN junction over there. So any process that is happening can be of a non-reversible nature in the long term. So it is always good to correct the thing as it happens. So in central inverter, we have the concept of negative grounding, which takes care of any negative to ground voltage that is being developed. In case of string inverter, the DC tends to be floating. So since these inverters follow a topology called neutral point clamp topology, so it is a 3-level inverter. So you have the third level being the zero level. So what usually happens with string inverters is you can actually raise the neutral point voltage. You can give a bias voltage at neutral point, so as to counter the voltages that are being developed from negative to ground. And this thing can be achieved inside the inverter and outside the string inverter as well. And this acts in the same manner and counters the PID in the same way, and there will be no negative to ground voltage happening in this scenario. So anti-PID is achieved in this way in SUNGROW inverters.
Good. So this gives comfort, a lot of comfort. So Ravindran sir, you can also put your own experience, because you have a lot of plants where I'm not sure, but yes, maybe they may be suffering with PID, that how you have tackled them and how you are comfortable with this string inverter philosophy.
Right. Luckily, I've had only few failures on PID, primarily probably because we have mostly used central inverters. PID is essentially because the voltage of the cells with respect to the frame, when it is when there is a huge difference, frame is already grounded. So when there is a differential voltage, you're having the ions moving from the glass into the cell, and it is essentially uh, deteriorating the function of the cell. Luckily, the PID is reversible in case of poly and mono modules. It's not reversible for thin film, is what I'm told. But poly mono, it can be quite easily reversed if it is identified. But by the time people identify it, it's like many months, many years sometimes of energy is lost, right? And it can be very substantial. They could be losing 5, 10, 15, 20, 30% also energy through PID. In central inverter, it's pretty simple, as you mentioned. Uh, by simply the impedance grounding of the negative, we are achieving the effect that the cell voltage with respect to the frame is always positive most of the time, or it's less negative than what it would be. In case of string, they solve this by using the separate PID box, or it can be part of the inverter itself, where, for example, at night time it injects a small reverse current to reverse the polarization which is taking place due to potential induced degradation, and it's reversible. If this device is used right from the beginning, it is better. It ensures that this PID effect is not causing any loss of generation.
Right, right. So I'm sure the designers who are here in the listener mode today, so they may be taking care of this thing very well, because when we are introducing another device as a separate, let's say a NTPID kit or whatever, so we are increasing maintenance. Okay, so how number of devices may be increased in our balance of system, then definitely those are increasing the maintenance of the system again.
One
So
important,
Rajesh sir,
sorry to interrupt again. One important aspect is what we have to do with the module manufacturer. We have to work and make sure that they are choosing the cells which are specifically certified. The manufacturers have a protective coating to defend against this PID effect. So we have to ensure that the cells are tested and the manufacturing is consistent with the sample test that they have done for us.
right, right, right. So, Rajesh sir, you also have older plants. So, what is your experience saying here?
Right, right. So, just in continuation to Ravindran sir, basically, how to ensure from the module side, being my past experience, because since 18 year I'm in solar only, and I was in cell manufacturing, module manufacturing. I was in Mojabear and Indo Solar. So the important aspect is basically, uh, if you are selecting a cell, that should be as much as higher shunt resistance. Basically, there is a kind of different process. In the process, one process is called age isolation. So in the age isolation, you have to remove the kind of glass particle which are settled on the edges of the cell, and that is get isolated through either laser cutting, or either there is a kind of HCl or kind of chemical which is etching on the edges. So, and how you will measure it? You have to measure it by the your sun resistance measurement, and you have to see that the maximum 1,000 ohm will be there. If you will not be able to manage in the cell level, also you have to ensure the EVA, the ethynyl vinyl acetate, that is the part of module. So in that, basically you have to manage the kind of gel property should be as per the required spec. So this is the basically a sodium ion content components which create the kind of phenomena which is coming on the edges of the module because of the humidity and because of the surrounding environment. Once your the moisture will penetrate or it will be sustained on the glass, it will create the PID. So in the module side, definitely you have to check the cell and the EVA. Coming on to the central or versus string or either PID control. So best part what I found, because in the central inverter, people were doing negative grounding, but they were not sure about the negative grounding is working or not. Because the biggest problem in India solar plants, people are taking earthing very likely. They are not even maintaining the earthing. So this is the one of the good aspects which I found in the string inverter. There is a 50 inverters controlled by one, you can say, kit. That PID kit basically it's set up the voltage. So definitely it's giving the because it's a potential difference. So you have to maintain a you have to equilibrium or equalize the potential. So there will be a kind of voltage. Problem is that you have to ensure this voltage or this current which you are feeding, that should not come on the field, and there should not be a human safety violation. So that things we should maintain, or else I think string inverter is one of the best part which is giving the PID control, and that you can able to see in the diagnosis as well. So there are the software, there are the new tools available in the string inverters. In the O&M point of view, you can able to see the daily how much voltage you have injected, and vis-a-vis that this. So if your voltage injection is increased, because it is a 300 to 680 volt, if it is increasing, that means your PID or your cells or your modules are getting deteriorated. So best part in diagnosis as well, you will have good monitoring feature. Yeah.
Right. So really very insightful thing,
Thank
Rajesh,
you.
that you have elaborated the complete manufacturing process, that, and people are must be noting out of it that what we have to do, what we have to check during the module manufacturing process when we are doing a factory acceptance test or inspecting the factory, right? So over the pre-charge or DC charge kit or whatever the name Rishabh may be taking for it, for a string inverter, but how it works in the interest of the technical people who are here. Rishabh, can you elaborate on it?
Sir, the inverter converter topology is a 3-level neutral point clamped topology. So in the neutral point clamp topology, you have a DC link bus, and the center point of that link bus is tapped as a neutral, and that same neutral is also reflected on the AC side as well. So any voltage bias that we put either on the AC side or on the DC side will reflect in the shifting of the negative to ground voltages. So what we can employ is within the inverter, we can do DC side shifting, or outside of the inverter, we can do AC side shifting by applying that bias voltage, which can counter. Basically, it will follow your KVL, Kirchhoff voltage law, and it will negate the voltage and it will make it a positive voltage, so that there is no potential induced degradation that may take place. And potential induced degradation is basically your accumulation of the carriers which will obstruct the flow of the majority electrons crossing the barrier potential. So over the time, that reduces the current handling capability of the module, and it reduces the power of the module. So initially it is reversible, but over the time, as the things become hard and fast, then the complete effect will not be, even if we try to put a bias voltage, it may not be that much. The efficacy might not be to get it to back to 100%. And then there are two methods I would like to elaborate about PID. One works during the day actively, and one works during the night. That is called PID recovery, which works during the night, wherein we put a positive voltage, and overnight it will try to correct the charge that has accumulated on that barrier potential over there. And during the day, it is actively cancelling the voltage that is creating between the negative to ground. So there is no chance of PID happening during the day if you're using anti-PID. So these are the two things which are there.
Okay, so Rishabh, it's really interesting, and also I can understand that you are giving more numbers to your second baby, the string inverter. Okay, but I'm just concerned about the grid requirements also sometimes. Okay, so in case of, let's say, Q at night, so that feature is well available with the string inverter.
Yes, sir. That feature is available. And if by chance you're opting for PID recovery, then both the functions cannot simultaneously work, because queue at night will involve charging of DC bus while keeping the PV field isolated. And here you are required to charge and you have to correct the imbalances that have happened in the PV field. So both the processes do not happen simultaneously. So this is impediment if we are trying to work with PID recovery and queue at night feature. But at the same time, we do have anti-PID, which is working during the daytime and actively cancelling out any potential that is created between negative and ground.
But this needs to be actually we cannot, when we are putting large scale plants of let's say 300 or 400 or 500 megawatt, in that case, as far as the requirements are concerned from our CA or maybe POSOCO, so we need to feed the queue at any point of time, not only day, it's also night, because they can ask for queue for voltage regulation at any point of time. So this thing also I think the panelists should keep in mind while giving more marks to the string inverter than central inverter. This is also very very critical topic which definitely everybody needs to follow. So, right, no problem. So there are when we are going into the selection mode of the central inverter or the string inverters. So there are recent changes in the BOS requirements or specifications. So Rabindran sir, can you elaborate this part?
You want me to talk about the BOS or the inverter itself?
BOS specifications for the inverter systems of let's say central as well as versus comparison to string inverters.
Okay, not much change coming due to the inverter per se, but more the module is driving the selection of string cable, the fuses, the Y connectors, the combiner boxes. Those inputs are causing a lot of change in the BOQ as we go from one module to the other. Especially if you have the two extreme cases of regular current and then the high current versions of module. And to that extent, it varies the number of inputs in the inverter. But barring that, not much on the BOP. But on the, like you were saying, on the grid side, there is a lot of new requirement I'd like to talk about. One is, as I briefly mentioned, the steady state behavior, which is mandated by the CA technical standards for connectivity to the grid. Though they are, the requirements are a little vague there. It's not very well spelled out, but the underlying interpretation is that you have to be capable of, responding with reactive power as and when the grid demands to the extent of 1/3 of your capacity, which is equivalent of 0.95, and so on. And especially what happens in the transient condition, the priority is given for reactive power when there is a fault, so that the reactive power is fed into the fault voltage, which is sinking to say 10%. Instead of that, when you give reactive power, it comes up. All these aspects are important. But going forward, if you, in fact, looking backward, the early days when we had solar PV connected to the grid, people were saying, okay, if there is a grid disturbance up, you get disconnected, you come back, join back after the fault is cleared. What's the problem, right? Nowadays they are saying, you please remain connected. You just ride through. Don't fall off the horse. Just ride through. Stay with us, right? This is what they're saying today. But my very honest conviction is that maybe 3 years, 5 years from now, people will say, please lead the way. Meaning, if there is a fault, the solar and the wind inverters will have to mitigate the effect of the fault. They have to handle the effect and keep the grid stable. Whereas yesterday they were just going off the grid. Today we are just remaining connected. Tomorrow we have to take control and manage. Because why? Because the larger rotating machines are all getting retired. More PV penetration means the inverter characteristics are going to change a lot. One such characteristic is the ability to work in a grid forming mode. For example, if the grid is islanded mode, then the inverter itself has to generate the voltage and in a voltage source converter fashion, not as a current source but as a voltage source. That is one. Second is, like I said, the ability to feed fault current means at that very instant of fault, maybe for half a second, inverter should be capable of giving double its rated current. Right? Today's inverter, they just clamp the value at the rated value. After a few microseconds, they just clamp it to rated value. Grid forming, I said. Similarly, the ability to work in a group, all inverters together in a grid forming mode. This is more stringent. This is more difficult to achieve. Today they say, please use a PCS, use a battery to form the voltage, and then we will follow. Right? So the days are coming when only solar inverters will be able to take the lead here. Of course, battery support is required, but quite a lot of the lead can be taken by the solar inverter. Similarly, in a weak grid where you have solar plants coming up in remote locations, and very often the short circuit ratio is much lower than 5. Currently, in fact, I'm working in a project where I'm barely able to reach a short circuit ratio of 1. Right? So we are looking for very stringent requirements from the inverter to be able to handle this very weak grid. Weak grid by definition means that if the inverter load is changing, the terminal voltage of the inverter should not change much. So that is the definition of a strong grid. If that doesn't happen, it's a weak grid. So why that is important? Because if the voltage changes, the inverter gets confused, and you have a lot of stability issues. So this is one very important characteristic for an inverter going forward, that it has to be able to work correctly in a weak grid. There are many such similar requirements for grid behavior of inverter. At the moment, I believe that central inverters are advanced by a few years in providing these solutions, but I don't see why string inverters cannot. They are also technologically capable of providing the solution. The other aspect you touched upon about response time. Now that's a technology solution. I'm sure we can find a solution to that, so that the string inverter also can respond in very high speed to commands from a central device like a power plant controller.
Right, Rabindran sir, very, very important message you have given to everybody, that because when we are saying that we are, let's say 10% or 50% to 15% today, tomorrow as soon as we are targeting, we will be 50% also very soon. Okay, so when we are putting more penetration of the renewable energy component into the grid, then we are not just the minorities here, right? So we have to put as a renewable energy good partner, so we have to put our efforts into stabilizing the grid at all point of time, right? So, and grid, definitely once we have a strong grid, then definitely the things can be sustainable more and more. So yes, so it is the responsibility of solar and wind suppliers also to become more and more competent and find some futuristic solutions in order to make the grid more and more stable for 24 hours a day and 7 days a week, right? So Rajesh sir, you also means, I think it's your turn now to put some light that we are increasing the voltage from 1000 to now 1500, maybe 2000 someday also. Okay, so how the BOS things are changing day by day?
Of course, see, BOS part, if we compare like the technology enhancement, that definitely going to be reduce or provide me more support on the design. But important is that you have to change complete product value chain, or you have to take along with all the suppliers, all the materials which are available. Like inverter is in the plant, it's a center part, it's interfacing with the DC and it's giving you AC. So in DC side, if we talk about like central inverter was a proven technology, but they were struggled a lot during while coming on the 1500 volt, because at the 1500 volt DC fuses were not available. Uh, the module manufacturers were ready to provide you the 1500 volt insulated panels, and you were like searching how like which Socomac or Copper Bushman or whoever is, like they were like ETA or so OEMs were making themselves ready. So if we going forward 2000 volt, so definitely it is going to help us the system, but in the same time there will be a kind of DC switch. So in the DC switch, I found this one of the problem, that there is a no arc separation. So these type of things we have to take care, because some of the string inverters, they are like coming with the DC switches, but once in the on condition, if we isolate, if you want to turn off the DC switch, want to disconnect that, getting an arc, and through that the inverter is getting burned. So that is one of the problem. In AC side, there is a kind of LT panel. So if 2000 volt will come, then definitely there will be also the ratio may increase, or 800 volt to come 1000 volt AC. So 1.1 kb will also be there. So availability of MCCB or availability of switchgear is also required. So definitely this is helping to reduce the BUS, but technology challenges will also be there, that we have to manage.
Absolutely right said, sir. So we are taking a note of it. So regarding the inverters, either it is central or string, maybe when we are focusing more on central inverter, let's say, and we are generating during the peak hour conditions, okay, when we are having 1000 watt radiation or maybe more also. So generally, in generally in Rajasthan or maybe Gujarat or maybe Karnataka also, the temperature of the field, especially in Rajasthan, becomes 45 or 48 degrees centigrade, right? When we are saying the temperature of the field means ambient temperature conditions. So ambient temperature is 48 or maybe 50 degrees centigrade also during the peak generation hours. But at the same time, right, so when the cooling air is being sucked by the inverter, especially central inverter, and then it tries to cool itself for making it more efficient. So I have seen, I have means not only I have discussed also at many places that the inverter starts degrading itself. Okay, so when we are saying that it is 1 MVA inverter, so 1 MVA inverter is at some specific temperature, right? So when the temperature is keep on rising, then definitely the components which are semiconductor or maybe other devices which are being installed inside the inverter, they tends to degrade one by one. So ultimately the inverter puts itself on the degradation mode and power clipping start happening, right? So Rishabh, how you are taking care of the cooling solutions? So are you still working on the same cooling solutions which we were working from last 5 years, or you are trying to design some more effective cooling solutions, maybe some water based cooling solution, or maybe some other? It's just a way question that you should put a technical light on it.
Yes, sir. I will elaborate on this. So, coming from like last 5 years, earlier you would have seen that the inverters used to be containerized solution, and containers are a standard 10 feet container or a 20 feet container. So, in a 10 or 20 feet container, whatever things you have to follow, you can follow as per the design of the container. Nowadays, the inverters which are coming are outdoor type inverters. So they allow you a lot of flexibility in designing how the air paths will be and how you want to cool what type of equipment. So SUNGROW has followed two-part cooling philosophy for all the outdoor inverters, wherein they segregate the high heat generating parts like the IGBT and the reactors, and the very sensitive parts like the electronics and all, they are provided with closed loop cooling with heat sinks, and the IGBTs and the reactors, they are provided with smart force air cooling. And what we have usually done is we have improvised on the cooling methodology, how the cooling path is followed. So we have a distinct cooling path. We have a top-down or a sideways approach, wherein we have a very short path between the air inlet to the air outlet, so that the air is sucked down very fast and it can evacuate heat at a very fast pace because of a very short path from where the heat is being taken and being taken out. So such small measures have been taken to improvise the inverter performance, and they allow the inverter to perform in such rugged environments, which are the desert environments, flawlessly with the rated wattage. Yeah.
Right. So Rishabh, I actually when it is a practical thing also, when we see that the inverter is going into degradation mode, let's say, okay, it is clipping up the power. So why it clips up? Because the temperature is going beyond the limits, right? So but why the temperature is going beyond the limits? Because if we have, let's say, 100 inverters in the field, and we can easily see, because ambient is same for every inverter, right? So we can see easily that few inverters are going degradation mode, few are not going, due to n number of reasons, right? So we generally see it's a very means a basic or a laborious kind of requirement to clean the filters on time, right? So filters are not generally people are cleaning definitely, but they should be having a change phenomena, like after 1 year, every year, so we have to change the filters, or we have to clean the filters at this duration of time. So whatever the precautions we may take during that time also. But yes, so I would suggest you or maybe your technical team, that you should provide a feedback kind of thing, that yes, inverter is going in the degradation mode, okay. So as we are giving a address register for power, for reactive power, voltage control, everything is available on the Modbus platter, right? So on the same Modbus front, you should be able to give a indication that inverter is going on degradation mode due to, let's say, heat sink temperature or IGBT temperature or ambient temperature, or maybe whatever kind of degradation pattern your algorithm may be following. So you should be giving that, so that people are getting alarmed that yes, my inverter is getting into degradation mode. I must go to the inverter, clean the filter, or see that what is happening with that particular inverter, so that they are getting maximum generation from the available resources. So I think Rajesh ji and Ravindran sir also agree on this part.
Yes, definitely. Yeah.
Yes, I also feel very strongly about it.
So we have added some more things, like instead of using like fiber-based filters, we are also trying to do with steel mesh type of filters, which will not get clogged so easily, and they will have the air paths in accordance to their design, so that there is no accumulation of dust. Same way with the top-down approach, based on gravity, there will be no accumulation of dust because of the gravity, and the fans and all will not require that frequent maintenance. So such type of value additions we are also trying to do, so that in the desert type environments, it does not affect that much on the O&M activity to be done so frequently. So such changes are there, and we have taken your feedback, sir. We'll definitely pass on the information to R&D to work on these points as well.
Much appreciable. So I think we are done. So now over to Priyanshi for taking it forward for the Q&A session.
Yeah, so we have quite a few questions in the Q&A box. Atul, so you can choose a few and I can display it on the screen, and then speakers can take it, and then we can have Rishabh sir's presentation. Or you would like to
Right,
have the
right.
presentation first?
Let's have the presentation. So until I'll read the questions also.
Yes,
So
yes,
Rishabh,
that's
over to you.
Thank you so much, sir. I hope now it works properly.
sure, side will.
I hope you're able to see my screen.
Yes, we are able to.
Okay, so this is about SUNGROW India Private Limited. We are the world's most bankable brand, 100% bankable for last 3 consecutive years, based on Bloomberg NEF studies. So you can see how the company has grown from landmark to landmark, right from the initiation in 1997, and come 2021, we are ranked amongst the top 500 ESG excellent enterprises in China, and we have won several awards on the way to achieving this. So our company mission is clean power for all. Our vision is to be the global leader in clean energy conversion technology. Our values are being sincere and pragmatic, precise and open, and being customer oriented. So we have several business verticals, the prominent one being the PV inverter. We also have a renewable energy investment and development business. We are also working in energy storage converter solutions and the complete systems. We also develop wind energy converters. We are also into NEV driving systems, floating PV systems, the plant maintenance, electric vehicle charging equipment, intelligent PV cleaning robo, and renewable hydrogen production system as well. So as you can see, our revenues and shipment have grown from year to year, and shipments, especially last 2 years, have grown manifold. And we are ranked number one globally for last 4 consecutive years and number one nationally for 10 years. So research and innovation forms the heart of SUNGROW. We have more than 40% of the total employees who are dedicated in R&D, and we have the leading pattern for IPD for the product development process. We have the world's largest inverter factory, with China factory churning out 100 gigawatt per year, India factory being 10 gigawatt per year, and ESS as well 6 gigawatt hour capability. So SUNGROW is world's most bankable inverter brand with over 224 gigawatt installed worldwide as of December 2021. We have power installations in more than 150 countries, and trademark of SUNGROW has been registered in more than 160 countries and areas. And you can see our various inverters installed in India. So greater than 224 gigawatt installed worldwide, with many large-scale plant references in and around the world, including India. We also have quite a large number of references for energy storage projects, which are wind and ESS projects, microgrid projects, and DC coupling projects, and several other types of energy storage projects. Now we'll come on to SUNGROW in India. So SUNGROW entered India market in 2014, and first batch of central inverters were installed in 2015. From there, we crossed 1 gigawatt shipment in 2017, and in 2021, we have achieved 11 gigawatt plus of total shipment, and we have also expanded our local manufacturing unit for 10 gigawatt annual capacity. So according to independent research institutions, we have been a leading inverter supplier, we have been leading in inverter installations, and we have been leading in market share based on various periods of time till today itself. Our numbers of inverters are growing in India, and for more than 2,800 days, inverters have been running successfully. 13 gigawatt shipment crossed till date, 40,000 plus inverters supplied, 25 plus states, and 350 plus members. India's largest inverter factory, we have a factory which is having a 10 gigawatt per year production capacity, and we are dedicated towards Make in India mission as promoted by the Prime Minister of India. We provide solutions catering to all types of environments like string inverters, central inverters, residential inverters. We also provide systems like DC to DC combiner boxes and DC to DC converters and DC combiner boxes as well. So Indian factory achievements since the inception is 15.5 gigawatt plus of total shipment of India and overseas. Made in India inverters, 30 plus models, 16,000 plus inverters manufactured for India and overseas, and more than 300 jobs have been created locally for Indian factory. We have the biggest service network with a local service team of 35 plus members and 10 plus warehouses and repair centers spread all across India. To meet the customer demands for the PV plant, we have several products being pitched in the Indian market. As you can see, for utility segment, we have a host of central and string inverters. For C&I segment, for residential segment, and we do provide the related accessories which are required for monitoring. And we do have a SunPure Robo organization which can provide autonomous and semi-autonomous robots. We have ESS products as well, ranging from the power converters to power converters and battery packs together, and the auxiliary equipments like the DC to DC converters and the EMS, BMS, and all the monitoring solutions that go to make it a complete ESS system. Our utility scale solution, we have SG320HX, which is the newly launched inverter, and we have the steady workhorses SG250HX-IN and HX-IN-20. So for the new model, as I was referring to, we have two variants, and we allow a high flexibility in the DC and AC ratio. Same way for utility scale solution for flat terrains, we have multiple products which are ranging from single MPPT to up to 4 MPPTs, which are highly integrated with low system cost. The latest one being the 1+X series, wherein you can achieve 4 MPPTs and up to 8 MPPTs per block with a flexible design and option for DC to DC ESS interface, and having a plug and play design with no much professional help required for carrying out the maintenance. We have the C&I solutions in form of SG110CX and SG33 and 50CX. We have the residential solutions as well. And these are made in India product for India and overseas markets, being manufactured in Indian factory, which includes entire SUNGROW range for utility and C&I segments. We have won a lot of accolades and awards from various independent bodies. Our products have won Innovation Award for their design. We have won the State Annual Solar Awards as well. And employees form the crux of any company, so there is a high amount of employee engagement activity that happens at SUNGROW. All the employees we have a diversity in thinking and inclusiveness that results in a winning team. SUNGROW also does CSR tree plantation drive, which we are executing with the help of Sankalp Taru Foundation to plant different trees in different states on the behalf of the customers. And these are our reputed customers: Adani Renew, Azure, Hero Future Energy, O2 Power, Sterling Wilson, Acme, Greenmax, Ayana, Greenco, Radiance Renewables, NTPC. So all major organizations which are working in the field of solar are utilizing SUNGROW products. So that's all from my end.
So great, Rishabh. Very good efforts, and these are very much appreciated also in the market. I also personally appreciate the efforts you people are putting into keeping very high uptime for the inverter. You are responding to the calls very well and taking care of the inverters which are installed in the field very well. So I have
Thank you so much.
very quite informative suggestion for you, that when we are we are buying an inverter, let's say, so you are giving 5 years warranty generally. So you are also giving a extended warranty for next 5 years, right? But when we are installing a PV plant, so we intend to generate the energy for 25 long years, right? So generally we have PPS for 25 years, right? So you should, as SUNGROW being a very large organization, you should also be thinking on some buyback philosophy or something after 10 years of time, because we can give you the inverter back after 10 years. You can install a new technology or something inverter, because you can do a lot of things with that particular inverter, right? For us it's a scrap, okay, but for you as a OEM of the things, So you can do better things, or you can refurbish it for some smaller means organization, or some smaller people who are installing only few kilowatts or something. So you can sell them back after some refurbishment or something. Just like we are giving our car to the to the dealership, and they are offering us the new car. Okay, so in that way that can also work, and that will be the future definitely, because the after warranty prices for the extended warranty are very high, we can say. So that makes the system complete unfeasible for many of us. Okay, so it's a suggestion for you. You can talk internally about it.
Sir, yeah, your suggestion is well taken, sir. But we would not want you to discard our products. And with regard to the design, we are trying to future-proof the design of the inverters. As you can see, sir, SUNGROW is trying to bridge the gap. Earlier, central inverters used to be at a very high kVA rating, and string inverters at a very low rating. Now, sir, you will see that the gap is bridging up. The difference is also coming closer. You are having almost a 300 kilowatt string inverter, and a central inverter is starting at 1.1 megawatt, multiples of that. So we are trying to bring all the things closer, and a special emphasis is given that plug-and-play solutions are there. No high maintenance and highly qualified maintenance personnel are required at site. So this type of approach will, I hope, will augur well for your plant for a longer running period, sir. And we do design our inverters for 25 years of operation. So we would want you to utilize them with a longer standing commitment. And we also have certain features that would help even further future proof them, like a battery interface that is being offered optionally in case you want to harness more amount of energy, since DC-AC ratios tend to be higher, and we have a lot of clipped energy because of the limitations on the grid side, which will be becoming more stringent in the coming years. So we can harness that energy, and based on the time of the day tariffs, we'll be able to utilize those things as well. So yeah, that is from my side.
Very important, very good also. Right, so let's jump to the questions, which I think very few, but yes, very interesting also. So Pradyot have asked that what will be the impact on DC losses if you have higher wattage in string inverters without SMB. So I think you can answer it first, then we can take an opinion from our other panelists.
Sir, actually, a higher wattage in the string, and right now, since you're having high wattage in modules, so they occupy considerably less land mass compared to the smaller watt peak rating of inverters modules. So that will have a reasonable amount of DC losses. Though we have seen outside of India as well that people are opting for up to 10 square mm solar cables as well, if required, to have a larger area covered with a lesser amount of DC losses. So this is our observation, sir.
This is new, but in generally Indian context, we are using 6 only.
Yes, we are using 6, but as far as you know, like worldwide scenario is concerned, even 10 is being considered at several places, sir.
Okay. So Rajesh sir, you have any opinion on that?
No, I also agree with Rishabh's comment. Basically, the kind of module wattage is increasing. So earlier we required approx 4 acre per megawatt, but now it will be a 2 acre or 1.9 acre per megawatt. So the kind of area for the DC field is getting lesser. And with the string inverter, you are just connecting with the module strings. So your 0.5% DC losses, in actual it is coming 0.3, 0.4%. So I think with the string inverter, you are not you don't need no need to worry about the DC. You have to take care on AC side mostly.
Right. Ravindran sir, you would like to say something?
Yeah, nothing further actually. So long as you're taking care with the correct cable sizing, the losses should not be of concern. Manageable.
Right. So another question and multiple questions from Mr. Bhaskar S. So for a question directly to SUNGROW, do SUNGROW has any plan in coming up with 1500 volt DC in string inverters?
Sir, we already have 1500 volt DC string inverters since last 5 years. Earlier, it used to be SG 125 HP, that used to be a single MPPT string inverter. Post that, we have SG 250 HX IN and IN-20, and the recent model is SG 320 HX. So all these models have been compatible with 1500 volts, rated for 1500 volt DC systems.
Okay, 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 fine. So, next question by Mr. Bhaskar. It's directly on me. So, my question to Atul Pachori, one, how should we separate the module considering the degradation during the design stage? So, yes, so during the design stage, definitely the segregation is there according to the bin class. So, the module manufacturer itself sends the module by tagging them for the positive tolerance, according to the positive tolerance. So yes, so the EPC people, the project people who are or the planning people who are putting the plant into shape, they should take a very strict note of that, that the uh, dedicated bin class should be, and should be at the same MPPT only, right? So we should take care of this at the design stage itself. Then second question is yours. Since you are in O&M and you have seen many plants, kindly share your view on module degradation, and it is within the manufacturer claim. So yes, I am into O&M from long time. So from last more than a decade, I am into O&M and seen very first module also, which is being commercially installed. So degradation is a very relative term, okay, which we are saying. So as a developer or as a IPP, when we are installing a plant, we used to think that the modules will follow the degradation pattern which is being guaranteed, right? So usually the module manufacturers gives the product warranty of let's say 10 years and the degradation or power performance warranty of 25 long years. But when we are saying the degradation warranty and everything, so everything is roaming around 3 to 5%, right? So 3 to 5% is just a number for everybody, but when we are saying that 3 to 5% degradation in a plant before its age, it's a very catastrophic effect on the IRRs. Okay, so when we are sending the modules to some lab, because the module manufacturer do not generally believe on the only on the IV curve testing which we are doing at the site, right? So we can just imagine, or we can just put the degradation pattern as a whole. We can see that it's degrading. Yes, we can see that it's degrading more than what is being committed. We can see that it is degraded 1%, 2%, or maybe 3%, or maybe 5% from its natural degradation pattern. But when we are sending those modules to some laboratory, maybe in India or maybe to Germany or maybe Berlin or wherever we are sending these modules, so things are different when it is installed at site. Things are entirely different when we are sending them to the controlled laboratories. Okay, so degradation pattern may be differing when we are measuring those degradation at the site and measuring at the factory. So module suppliers, when some customer is raising some voice that boss, my modules are being degraded more, right? So you should be having some philosophy or some instrument or some equipment which is available itself in the country. You please come to the site, verify the degradation, and give the result on the spot. Okay, give your verdict on the spot, so that they are also happy, you are also happy. Or if you want to engage some third party for getting that degradation verification, then definitely you please put on it, right? Degradation is a very bad thing which can happen at any solar PV power plant. Because I'll take a very fair example for your information, that let's say if I am having more than 5% degradation in my plant. Okay, I am having 100% 100 megawatt plant, and it's a 5 megawatt plant, right? Now what is happening, you will give me 5 megawatt let's say a 3% or 5%, you agree also that yes, it is degraded more. So you will give me a new modules which are let's say equivalent to my 5% of the degradation. But what I will do with those modules, boss? I have a degradation in all over my plant, right? So even if I will getting modules which are let's say more than my degradation, but I will be able to change only those quantity of modules only, na? Right? So that will increase again my mismatch losses, right? So degradation is a very critical phenomena which should not happen in the plant as far as the plant health is concerned. But again, if it is again happening, then you should be having some philosophy or some mechanism to come to site to verify that degradation and can give a stamp to the developer rather than putting that module from the string, can sending to the some factory. A lot of hassle is there in sending those modules to some laboratory, because in transit also some damage can happen, and the modules are without any generation kept inside black boxes that may change the degradation pattern also sometimes. Okay, so this should be the phenomena for the module manufacturers, right? So I think Rajesh sir and Ravindran sir can also put some light on it.
No, it's right. Basically, there are in India nowadays mobile vans are available. So they are having a module tester in their lab or even in kind of container. And in the container, they bring the particular lab on the site. And with the controlled environment, they check the module degradation pattern and they will give the IV characteristics. So that is one of the way. And very initially, like during the design stage, of course, module allocation should be within like kind of their binning criteria. So that is also one of the very expertise things. Mostly in the project execution time, people are not taking care about that. So that is very important. If you are getting a kind of allocation mapping from the design side, please ensure while execution. Yeah.
Right. So rightly said, sir. But actually, the fact of the matter is that the module manufacturers do not acknowledge the reports what either Mahindra or Sterling or DNV or whomsoever the lab they are having. They are coming to the site. They are assigning the degradation. All those things are relative in nature. Okay, so the module manufacturers generally do not accept or give the warranty claims on the basis of those reports. That was the actually pain point, sir.
Mhm. So in that case, you have to send the TUV and other lab.
Third party, yes, a third party
Third
lab which
party.
is recognized by that particular module manufacturer, then
Yeah.
only they will pass on the claims.
Right. Right.
Right. So next question to Rishabh. Kindly explain how PID affects. Yes, this is already been answered. We can go to next question. In utility scale projects, string inverter monitoring is done using smart controller. How many inverters can be connected to one controller and it's through RS485 or any other communication like, okay. So this is very generic question. We can pass on this question to next. What is the accuracy class of DC and AC CT used in solar inverters? This is very important. I think Rishabh can all answer this. Rishabh, please.
Yes, sir. So accuracy class is 1% that is being utilized in the DC and AC side.
Okay. So again, very good, but this is something very important. Why SUNGROW averse to factory inspection? So you, Rishabh, you call Mr. Abhay directly, okay, and can invite him to the inspection.
Definitely,
inspection.
sir. We'll be happy to host.
Right. And does SUNGROW as derating testing in Indian factory? So you can say yes or no directly.
So we'll check with the factory and we'll see for which product they are referring to, and then we'll reply
Right.
to Abeji.
And what about the AFCI feature of 320HX?
Sir, in the standard version, AFCA feature is not there for this product.
Okay, fine. And then next question is, could anyone please summarize central versus string in all aspects? So for this, I think we have to, boss, we have to put all together a meeting so that we can, because it is subjective. Okay, somebody loves anything, because everybody is having their own verdict, and according to the modeling, the selection is being made. What is the role of DC connector in string and central inverter? Is it mandatory to provide the complete galvanic isolation? So I think this answer should be given by Ravindran sir. They have already emphasized on it, but yes, they can put more light on it.
DC contactor in the inverter on the DC input, especially if you are wanting to have nighttime VAR, as it was already mentioned, we need to disconnect the DC array from the inverter because we will be energizing the DC bus. That is one reason for disconnecting there on the DC side with a contactor. Otherwise, you can have a switch also with the which is motorized.
Right. So next and the last question is, what happens to the clip power? Is it converted to heat, or it's changing the module string current voltage to extract less power from DC side? So I think Rishabh, if you have something.
Yes, sir. So basically, the MPPT algorithm, any PV module will not be generating power on its own. You have to set the operating point to the knee point, that is the maximum power point. But usually, when we are going with DC side overloading, so that power will be achieved earlier than reaching the knee point. So the point will be varied, and then accordingly, the power will be extracted from the PV modules.
Right. So Akhileshji, actually, what happens when we are saying that we are clipping the power? It is just the adjustment of the MPPT. Okay. So that whatever we are intent to get the power from the DC field, we are getting that appropriate power only. So that work is being done very appropriately by the inverter. Okay. So that's the thing. So
Another way
I
of
think
saying it is the power drawn from the module is dependent on the voltage which is imposed on the module.
right.
If I choose the maximum power point voltage, I get the maximum power. If I increase the voltage above that, I get less power. Or if I decrease the voltage below that MPPT point also, I get less power. So the power which is drawn by the inverter is selected by the inverter based on its clipping limits. Uh, the wasted power, of course, is remaining in the module as heat. It is not going elsewhere in the inverter as this is one of my favorite interview questions, by the way. So
So very good. So thank you all, and over to Priyanshi now. You can take it forward.
Thank you very much to all our esteemed panelists for this wonderful session. And a very special thanks to you, Atul sir, for superbly managing the session. As always, you were impressively well prepared and extremely professional in the way you kept us all at the height of attention for almost an hour. Plus, you are phenomenal in making the panelists all appear at their very best. And also, special thanks to Rishabh sir for their wonderful presentation. Thank you everyone for extending your time and support for the event. We promise to come back with more such exciting topics very soon. Thank you all the attendees and the panelists. Thanks a lot.
thank you.
Thank you very
Thank you
much.
very much. Have a nice day. Thank you so much.
Have a nice day, everyone. Thank you.